Hi to all. So in this quick video, we will solve this two-step binomial tree for a put option. The whole objective is not so much to solve the tree for a put option, but to just see in practice how an American option becomes different from a European option because of this feature that with an American option, you have the possibility of early exercise, whereas this is not possible if you have an European option. So let's just assume the following values. This is the value for the U up factor, D factor if the stock moves down, and then this is the strike, which we will assume it's 52. And the risk-free rate is 5%. We will assume that the price now, once again, in gray, let me put it here. In gray, we have the stock price, and let's follow these steps we have been mentioning before. First step is let's solve for this tree, or let's solve for the stock prices in this at each one of the nodes of the tree. So let's assume here we don't have it, so I will assume that this initial price is 50. Okay, so then once again, what we can do is just multiply 50 by the up factor every time the tree is moving. We're moving up in the tree. You can lock this up factor formula either by pressing F4 when the cursor is over this cell, you press F4, and this will happen. You will get these dollar symbols, or you can type them manually. You achieve the same thing. Once we have done it, we can copy and paste in an upper level, and every time we're moving up in the tree, and then we can even copy it here, and then when we are moving down, when we end up in the bad state of the world, we multiply the previous price at the previous node, the previous price of the stock at the previous node, and then we multiply that by the down factor, and we lock this down factor, so these dollar symbols are included too, so we can also copy. So now we have all the stock prices of our tree, and this is how it looks. Now, the next step we should follow is to complete the intrinsic value. Now, one important thing is that in this two-step tree, we only need the intrinsic values at the terminal node, so t plus 2. So let's do it. Now, let's keep in mind this is a put option, so the intrinsic value is a max of the strike minus the stock price, which we have here, or 0. And then the other thing we should do is that strike, we should lock it, because then we can copy this formula in every one of the nodes. Now, we only need the intrinsic value in the terminal nodes if we're calculating the price of this put option, which we will end up getting here at node A. However, just to illustrate the difference between an American option and European options, let's calculate the intrinsic values in for each one of the nodes as well. So we just copy this, and then because I have locked the strike price reference, cell reference, we can just paste it in every one of these nodes. Now, so we have this. One last step is let's start getting the price of the put option. Now, just for completeness, I have added this blue. I have shaded these cells in blue, and then I will calculate something that I will call quote unquote the price of a put. But technically, we don't need to do this because the price of a put option at expiration, which is this node, terminal node, is exactly the same as the intrinsic value. So as a matter of fact, I'm just going to type equal to this. So the price is exactly the same. And now arbitrageurs are in charge, are going to ensure that this rule holds. given that if that rule is violated, then we would end up with an arbitrage opportunity, just pushing the price in the right direction so it converges with the intrinsic value. Now, when we move, once we have the intrinsic values and we are solving for the tree, we solve for the tree backwards, which means now we go back here, and back here, now we need to use the pricing formula, because at expiration, the price, shaded in blue, right, the price, it's very simple. It's exactly the same as the intrinsic value. But when we move back in time and we are not at expiration, now the price is not the same as the intrinsic value. For instance, in node B, the intrinsic value is 0, but we know that when we use this general pricing formula for the option, we will end up with some value. And that value is coming from the possibility, from the fact that even though the option has no value right at that node, at node B, it is out of the money, which means that the price of the stock is already higher than the strike. So at that point, it doesn't have a value, but it could potentially get in the money if we end up in the next period in the bad state of the world here, and the stock moves down to 48, we would end up with this put option being in the money with a value of 4. So that value, that potential value in the next period, is then factored in the price of this put option at node B, because someone buying that put option is buying something that is worthless at the time, but that asset, that option, that security could potentially end up having some value in the next period. And there's a probability 1 minus p of that happening. So now let's get the price. And the price is, well, in order to get the price, we need the probability of a stock moving up and probability of stock moving down. In other previous videos, I have been working in this in more detail and mentioning what the formula for P and 1 minus P is. But here I'll just quickly do it, which is 1 plus the risk-free rate minus the down factor. And then we just divide that by up minus down. Let's keep in mind the formula for P and 1 minus P does not change for puts and calls. It's the same, because this is the same as well for the stock option. And so now we have this probability of the stock moving up, and then 1 minus this probability is the probability of the stock moving down, which is 1 minus P here. Now we have our probability, so we can use the general pricing formula at node B in order to calculate the price of this put option at that node. And the way to do it is, well, probability of the stock moving up multiplied by the price of our put option if we end up in that good state of the world for the stock, plus probability of the stock moving down multiplied by the price of our put option if the stock ends up in the bad state of the world for the stock. Bad state of the world for the stock is a good state of the world for a put option, right? And then we divide that by 1 plus the risk-free rate. Why? Because if you think about this numerator is just an expected value of the put option on the next period. So, right, that is the value we may potentially have reached, but that would happen one period later. So we have to divide it by 1 plus the risk-free rate, which in other words is we're discounting it to present value. And right now we're at node B, so we just need to discount it by 1 period. There's no need of raising it to the power of time, because we will bring it to present value one step at a time. The other thing is to keep in mind that this we are just dividing by 1.05, 1 plus 5%. And this is, we're oversimplifying things and to keep this simple and intuitive. So we are assuming that this risk-free rate of 5% is the rate that corresponds to the length of the step of each step of the tree, and that those two things match, that is exactly the same rate. In real life, we would need to adjust it, an annual rate, and adjust it by the length of the steps of each step of the tree. But for now, we can work with this, and we just lock this risk-free rate, because then we will copy and paste this formula, and we also lock this probability, and we also lock the probability of the stock moving down. That's by, once again, by pressing F4 or adding the dollar symbols, and that's it. Let's remove a couple of and keep 1.43. Then we can copy, Control C as in cat, and then we can paste, Control V as in Victor, and then there we go. We have the price here. If we just paste the cursor here in the formula bar, we can confirm that, yeah, the formula was updated correctly when we copy and paste it, and moreover, we can copy and paste it here. Now, this is amazing because we have calculated the price of the put option here. But there is a little problem here, which is, if we recall, there is this rule that the intrinsic value of an option sets the minimum price of that option. And that holds. There are some adjustments if the option is European, so it's not exactly the intrinsic value, but if the option is American, this rule works as simple as that. The intrinsic value sets the minimum price of an American option. Why? Because if the intrinsic value is ever greater, you could exercise and you could just reach that higher intrinsic value if instead of just settling with the price you're calculating from the future period. So in other words, if you're a rational investor, the expected value on the future period, you bring it to present value, and you would get a lower value in the future period if you hold the option than if you just simply exercise it now. So what we do in this case, and we can see that this is happening right here at node C. And what we see that is happening is that the intrinsic value, which is the green, the number shaded in green, the cell shaded in green, is higher than the price we're getting here, which is coming from the two possible prices of a put option in the next period. So in this case, we have to do something which is a manual adjustment to this tree. And basically, it is quite simple. We will just remove this, and we will substitute it. We will just remove the price, and we will substitute it by the intrinsic value. So I'll give it even a different color. Just in bold, red. And then now we know that we have adjusted this price here manually. We can keep the same color because it's telling us that this is the price. But long story short, we have adjusted that manually because otherwise we had a price 9 point something, which was below the minimum possible price. So we are adjusting it. Now we have 12 here, and as you could see, the price went up to this 5.14 instead of the previous price, which was, I'll take it back, 4.25. So then it's moving up to 5.14. Okay, so now this is the distinction, and if we think about it, we have the possibility of early exercise in an American option, which gives us access to potentially to a higher value whenever this something like this happens. So this convenience or this feature is an attractive feature for any investor. And for that reason, if you have this possibility, Like if this is an European option, you could not exercise at this node because you can only exercise at the terminal node. So we were able to do this adjustment because this is an American option. So we are able to exercise in order to just lock this higher value of the option, and not instead of the price that is coming from the pricing conditional on the future prices depending on the good state, bad state of the world, and the probabilities. Okay, so long story short, because we have that feature, whenever we consider two options, and let's assume two options that are identical, one is American, the other is European, but they're both identical regarding every other aspect. If that was possible, then we know that the American option would be priced, would have a higher price, because this early exercise feature is a feature that is actually priced in the option price. So it is added to the option price because it is an attractive feature to any investor. Okay, so thank you. This is with this we wrap this up, and thank you for your attention once again.